So this is our product. We're Team 20. It's called the Smart Can, and we built it to stop the rat epidemic going on in New York with the wastage of food, and also to try and reduce carbon emissions in New York from from garbage trucks, because the mileage of the average garbage truck is 8 miles per gallon, which is horrendous. So we're trying to reduce the amount of gasoline used. First of all, by having sensors inside here which detect the level of trash, which we use to input into our application to determine whether or not the garbage can is full. And if the garbage can is full, then we list it on the route that the garbage drivers have to take in order to optimize their routes to make sure that they're driving less. And inside our trash can itself, we also have 2 individual mechanisms that make it up. So on the left side, we have a set of a 1-to-2 ratio of bevel gears run by a stepper motor, and this is what turns our auger up and down depending on the size of the trash that's incoming. And if you look down there, our auger is also powered by a stepper motor with 2 V-helix gears, also in a 1-to-2 ratio. And the reason we chose these bevel gears and V-helix gears is because we wanted to maximize the torque possible with our stepper motors, because although stepper motors are known for having high torque, they generally aren't a high enough ratio to power things that need to have crushing force. So that's why we chose to opt for 1-to-2 ratios, and also use bevel gears and double V-helix gears as well. A big challenge we ran into was the fact that we didn't have collars or hubs to make rotational motion, so we met with this challenge by using these odd shapes as axles in order to ensure that whatever object is placed on the axle turns along with the axle regardless, without a set pin. So for example, on our auger, you can't really see it, but we have a plus shaped axle in there so that when the plus shape turns, it also turns the auger with it. And also right here, if you look, we have a square as an axle up here, and that attaches to this. So when this turns, like the square axle is turning, it's also bringing the entire mechanism up with it without using any collars or set pins or hubs at all. So that's what we're really proud of in terms of our design. And in terms of things we learned, a big thing that we learned is that you can also use 3D printed bearings as long as you sand both the bearing and also what the bearing is going into, because generally it's been stated that it's not good practice to use 3D printed bearings against any sort of material because of the high friction. But we found that it actually becomes pretty smooth after you sand them down enough. So what's next for us is to continue designing and make a better reiteration of the Smart Can, and also to try and actually publish the code that we've made for the Smart Can to try and impact the New York community. Thank you for your time.